Yeah. So the chapter is real numbers. In that introduction, I will explain what are real numbers and all. Okay. See, before knowing what are real numbers, first you should understand five types of numbers. First one natural numbers, second whole numbers, third integers, fourth rational numbers, fifth irrational numbers. First you understand these five types of numbers, then you will understand what are real numbers. Okay, I will go one by one. First I will take natural numbers. So we will write natural numbers like this. So this is 1 2 3 4 5 etc 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 dot 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 dot. See, this is called set of natural numbers. N means natural numbers. Okay, natural numbers. Okay, so this is open flower bracket, this is closed flower bracket. So natural number starts from 1 2 3 4 5 dot dot dot. So dot 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 means these numbers will continue till infinity, like after 5 6 7 8 9 10 11, like that till infinity. Okay, that's why I put dot dot dot. Okay, so these are natural numbers. Next there is other type of numbers called whole numbers. Whole numbers. So whole numbers are represented by W, and we will write like this: 0 1 2 3 4 dot 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 dot. See, these are the set of whole numbers. So whole number starts from 0, then 1 2 3 4 5 6 7 8 9, like that. So dot 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 means these numbers will continue till infinity, like after 4 5 is there, 6 is there, like that. Okay, now see, whole numbers, natural numbers are looking same, right? Similar, looking same. See, these are the natural numbers starting from 1. So you can see in whole numbers also there are natural numbers, correct? Starting from 1 2 3 4 dot dot dot. So starting from 1 until this side, so these are natural numbers. So these are, see, these are the natural numbers. Same natural numbers are present here also, but this I am telling whole numbers. So in whole numbers, natural numbers also present. Okay, then what is the difference between these natural numbers and whole numbers is, the only difference is 0. This one, 0. That means, so same natural numbers present in whole numbers also, extra is 0. In whole numbers 0 is present, that's all. So difference between this and this, in natural numbers 0 is not there, 0 is not there. In whole numbers 0 is present. Okay, so that is the difference between this and this. Next we have integers. So integers I'll write like this. So z is equal to open flower bracket dot dot dot. So minus 3 minus 2 minus 1 0, next 1 2 3 comma dot 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 dot, closed flower bracket. So this is called set of integers. So integers are represented by the letter z. So z means integers. Okay, so I put dot 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 here, means numbers will continue. See, after 0 this side positive numbers, plus 1 1 2 3. 1 means plus 1, like that. 1 2 3 are plus 1 plus 2 plus 3, both are same. This side negative numbers. So if you take 0, in this direction positive numbers, so in this direction negative numbers, minus 1 minus 2 minus 3. Dot 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 means these negative numbers will continue till where? Till minus infinity. Here I put dot dot dot, that means these numbers will continue till infinity, plus infinity. I mean, like after 3 4 is there, 5 is there, like that. Here also after minus 3 minus 4 minus 5 is there, like that. So this is set of integers. Okay, Now there is another type of number system, that is rational numbers. Yeah, I will show now. I will just erase this content. So any previous content, if you want to see, you can just move the video backward. Okay. So rational numbers next. Rational number, see, any number that can be represented in P by Q form, and this P and Q are integers. P1, Q are integers, and this Q should not be equal to 0. Okay. So this is the meaning of rational numbers. So what are rational numbers? Any number that can be represented in P by Q form. P and Q are integers, and this Q should not be equal to 0. So Q is not equal to 0. One example I will take. 22 by 7. Okay. See, this 22 by 7 is in the form of P by Q. Correct? So in place of P, 22, in place of Q, 7. P and Q are integers. Yes. 22 and 7 are integers only. Integers, just now I told, right? After 0, 1, 2, 3, 4, 5. In that 7 also there, 7, 22 also there. So this and this are integers. So first condition, P by Q form. So this is in P by Q form. Next, P and Q should be integers. P and Q are integers. So 22 and 7 are integers. So another condition, Q is not equal to 0. So in place of Q we have 7. See, 7 is not equal to 0. Correct? 7 is different, 0 is different. So definitely this 7 is not equal to 0. So for rational number, 3 condition. 1, P by Q form, and P and Q should be integers only, and Q should not be equal to 0. So this is the example. Okay, 22 by 7. So this 22 by 7 is a rational number. You got it right? So all natural numbers are irrational numbers. Okay, all natural numbers. For example, I will take 6. I will take 5. So 5 is a natural number, and this is also this is natural number, it is also rational number also. How? See, this 5 can be written as pi by 1, correct? 5 is equal to pi by 1, because if we divide 5 by 1, we get 5 only. So we can write 5 as 5 is equal to, so 5 as pi by 1. So 5 is equal to 5 by 1. Now you see this pi by 1. So this follows 3 conditions of rational number. This is first condition, second, this is third condition. The first condition is what? For rational number, the number should be in P by Q form. See, this pi by 1 is in P by Q form, correct? So in place of P we have 5, in place of Q we have 1, correct? Second condition, P and Q are integers. So 5 and 1 are both are integers, okay? And third condition, Q is not equal to 0. So in place of Q we have 1, and see, this 1 is not equal to 0. Correct, right? So 1 is different, 0 is different. So 1 is not equal to 0. So this is following 3 conditions. So pi by 1 is rational number. Pi by 1 is nothing but 5 only. Okay? So 5 is a rational number, and it is also natural number also. Because sometimes they will ask question, they may give some natural number, and they will ask you, is this rational number? Yes, that natural number is rational number. Like that you have to answer. Okay. So next thing we will see, irrational number is there. So next type of numbers are irrational number. irrational numbers. Short form of numbers is I have taken NOS means it's like numbers only. I have just written the short form of numbers. Remember, so any number that cannot be expressed in P by Q form, first point. So can't be expressed in P by Q where Q is not equal to 0 form. So irrational numbers cannot be expressed in this form, P by Q form, where P and Q are integers and Q is not equal to 0. So in this P by Q form, we cannot express the irrational numbers. First I will write one example. For example, pi only I will take. See, pi is an example for irrational number. Its decimal expansion is 3.141,592 dot. So this is an irrational number. See here, dot means these numbers. I mean, after the decimal point, whatever the numbers are there, these numbers will continue till infinity. So that is the meaning of dot. Numbers will continue. Okay. So this is irrational number. See, we cannot express this in P by Q form. Why? Because first point is this is non-terminating. First. Non-terminating. Non-terminate means stop, not stopping, not ending, like that. So meaning of this non-terminating, not stopping. Okay. So not stopping means after the decimal point, what are the numbers? They will continue till infinity. They will not stop at any point. They will continue till infinity. So because of that, we will say non-terminating. They won't stop. Non-terminate means not stopping. Okay. So this is non-terminating decimal number. Another thing is there, non-repeating. Non-repeating. So before understanding non-repeating, first I will give example for repeating. For example, say one number 2.5666666. See, after the decimal point, okay, 5 is not repeating but 6 is repeating. The 6 is repeating, 6, next after that also 6, 6, 6, 6. The 6 is repeating, right? So this is the repeating decimal because one number is repeating. So one number. Sometimes two numbers will repeat. For example, instead of this, I will take like this 5, 6, 5, 6 and all. So here, group of two numbers are repeating. 5, 6, again 5, 6. See, 5, 6, 5, 6, 5, 6. So two numbers, group of two numbers are repeating. So this is also repeating decimal. Repeating. I'll write here. Repeating decimal number. Sometimes three numbers will repeat. For example, like this. See, group of three numbers. Group of three numbers are repeating. 564, 564, 564. So this is repeating. You understood, right? So non-repeating means there is no single number repeating, or there are no group of two numbers repeating, or there are no any group of three numbers are repeating. Okay. If repeat like this, that is repeating decimal. If numbers won't repeat, so that is non-repeating. So I said this is non-repeating. See, after decimal point, you take any number. For example, I will take 1. So 1 is not repeating. After 1, 4 is there. But after in 4 also 1, if 1 is there, that is repeating. But after 1, 4 is there, it is not 1. But here 1 is there, but here again 5, it is not 1. Again 9, it is not 1. So this 1 is not repeating. If you take 4 also, 4 is here only, but here not 4. This is also not 4. This is also not 4. That means 4 also not repeating. For example, I will take group of two numbers, 1, 4. So this is group of two numbers. 1, 4 is here, but here it is 1, 5. It is 9, 2. So it is not 1, 4. It is also not 1, 4. So that means group of two numbers also not repeating. Similarly, group of three numbers also not repeating. So that is why this is called non-repeating decimal. Okay. If a number is non-terminating and non-repeating, both conditions should satisfy, then that number is called irrational number. Okay. So any number which is non-terminating like this and also non-repeating, when these both conditions are satisfied, then that number is irrational number. If only non-terminating but repeating, that is rational. Okay. Both should be there. I will write once again, you will understand. Let it be your C. For example, see 0.333333. So 3 is repeating. Okay, 3 is repeating. So now question arises: is this irrational number? No, it is not irrational number. It is rational number, because see, this is equal to 1 by 3. We can write this as 1 by 3. See, this 1 by 3 is in P by Q form. P by Q and Q is not equal to 0, correct? In place of P1, in place of Q3, and Q is not equal to 0. That means 3 is not equal to 0. So this can be written like this. This can be written in P by Q form. When we can express a number in P by Q form and Q is not equal to 0, then that is rational number. Okay. Remember, after decimal point, if the numbers are terminating, for example 5.656. See here, after decimal point, here numbers are ending, here stopping, numbers are not continuing. So this is terminating. Terminating means stopping. Okay. When the decimal is terminating, that is rational number. Rational number. Next, another example I will take. This only I will take 0.33333, and I will put dot 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 also. So after decimal point, numbers are not stopping like this. The numbers are continuing. Dot 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 means numbers are continuing. So when numbers are continuing means non-terminating. Non-terminating. But here after decimal point 3 is repeating. So that is repeating. Some student may confuse. Non-terminating means, so here non-terminating is there, so it is irrational numbers. No, not like that. If you want to say any number irrational number, so that should satisfy both the conditions. See, non-terminating but repeating, that is rational only. That is rational number. When it becomes irrational, along with non-terminating, it should be non-repeating. Non-repeating means after decimal points, numbers are not repeating. Along with non-terminating, if it is non-repeating, then only that number is irrational number. So if it is non-terminating but repeating, then that is rational number. Okay. Simple. For irrational number, you remember these two conditions. These two conditions should be satisfied. Now I will just give another example for irrational number. Okay. So one example for irrational number is 5. Okay. Another example is root 2. Okay. So value of root 2 is, in decimal we can write like this, 1.414213 dot 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 dot. So root 2 also irrational number. So I said irrational number follows these two. It satisfies these two conditions. First is non-terminating. That means after decimal point numbers will continue till infinity. So non-terminating means, see, after decimal points numbers are continuing till infinity. I put dot dot dot, that means numbers will continue till infinity. When after decimal point numbers continue till infinity, that means non-terminating. Okay. So first condition satisfied. Another I said non-repeating. See, after decimal point you can see there is no single number or group of two numbers that are repeating. For example, I will take 4. 4 is not repeating. After 4 it is not 4. Here it is okay. But after 4 all numbers should repeat. Only 1 4 is not enough. So here it is not 4. It is also not 4. So this 4 is not repeating. So I will take group of two numbers. 4 1 is there. Same 4 1 not repeating. This is 4 2. Here it is 1 3, not 4 1. So 4 1 also not repeating. So this is non-repeating. So since this is satisfying both the conditions, non-terminating, non-repeating, so this root 2 also irrational number. Okay, root 2 also irrational number. You got it right? The best two examples for irrational number is pi and root 2. Now I will say what are real numbers. Okay, so we discussed natural numbers, right? So n means natural numbers, then w means whole numbers, then z means integers, then rational numbers, then irrational numbers. Okay, so in this video we discussed these 5 type of numbers, correct? So all these 5 types of numbers together called as real numbers. You got it right? That is the meaning of real numbers. Okay, so there is another way we can say what are real numbers. I will tell that now. See, remember I said all these 5 types of numbers, 5 types of numbers together called as real numbers, correct? Now remember, see, natural numbers are also present in rational numbers. So whole numbers are also present in rational numbers. Even z, the integers also present in rational numbers. These 3 types of numbers included in the rational numbers. Irrational is different. So now we can say rational and irrational. Rational plus irrational together real numbers. Okay. So another definition for real numbers is both rational numbers and irrational numbers together will become the set of real numbers. Okay. So simple. Real numbers means both rational and irrational numbers are called as real numbers, like that. Because these 3 numbers are already there in the rational numbers. Okay. That's why. I hope you understood. Hey, thank you. If you like this, click on like and subscribe.